Welcome to the next lesson in the Searching Algorithm series. In this video, I'm going to discuss what is binary search, show you how to use binary search to find if a playing card exists in an array or not, and show you the algorithm to apply binary search using Python code. Binary search is an efficient algorithm that continually divides and sorts an array in half to quickly locate a target value. It starts by comparing the target with the middle element of the array and eliminates half of the remaining elements based on the comparison, continuing this process until the target is found or the search space is exhausted. Binary search is highly efficient for large sorted datasets. It significantly reduces the search space by half at each step, resulting in a faster search process, particularly when dealing with substantial amounts of data. Binary search is a favorable choice when working with sorted arrays or lists. Let's look at an example. We will be using an array of playing cards. A precondition for binary search is that the array must be sorted from smallest to largest. Let's find the 7 of spades in the array. We'll start by putting L, or left, at the beginning of the array, and we put R, or right, at the end of the array. The second step is to calculate the mid. The formula for mid is left plus right divided by 2. Left is 0 at index 0, and right is 4. 4 divided by 2 is 2, so the mid is at index 2. Next, we split the array into two groups. First, we check the card at M. We see that the 7 of spades is larger than the 5 of clubs, so it has to be in the second group. We simply move the left over to the second group, meaning that we choose the second group. And then we repeat the process. We calculate the mid. L is 3, R is 4. 7 divided by 2 is 3.5. This floor sign means that you round down, so the mid becomes 3. We then split the array into two groups again. We check the card at the mid again and see that the 7 of spades is here. So we have successfully found the card using binary search. You can return true or the index where the card was found. Let's do one more example and find the ace of spades. We already have mid and we split the array into two groups. Ace of spades is smaller than 5 of clubs, so it would be in the first group. We simply move R over to index 1, meaning we choose the first group. And we repeat the process. L is 0, R is 1, 1 divided by 2 is 0.5, and you round down, so the mid is 0. We split the array into two groups again. The first thing we do is check the card at mid. Ace of spades is smaller than the 2 of clubs. So we move R to this side. Notice that when R is to the left of L, this indicates that the ace of spades does not exist in the array. In this case, you can either return false or -1. Let's take a look at the Python code. So if we put L at the index 0 and R at the end of the array, as long as L is smaller than or equal to R, or in other words, when L is to the left of R, we calculate the mid index. Then we look into the array at mid. If we find a target, then we simply return the mid index. If our number in the array at mid is smaller than the target, it means our target is in the second group. So we have to move L to mid plus 1. Lastly, if it's in the first group, then we move R to mid minus 1. After the while loop, we know that R is to the left of L and that's when we did not find our target and we returned -1. Thank you for watching this video. I hope you've learned a lot about binary search.